Hey, what's going on, everybody? So in today's video, we're going to create a working weather app that fetches real-time weather data from an API. This is a massive project, so feel free to take your time. Take several days or even weeks if you need to complete this. Heck, you can even add this project to your portfolio. Well, let's get started, everybody. Alright, let's get started, everybody. This is a fairly useful API to get real-time weather data. The website is openweathermap.org. You will need your own API key, but signing up for an account is free. To create an account, we'll go to Sign In, create an account, enter your information, and then sign in. Once you're signed in, to find your API key, go to this drop-down menu, go to My API Keys, and you would just need to copy this API key. If the status is inactive, you'll need to toggle it to active, like so. Now, it may take several minutes for your API key to become active. Hopefully by the time of this project where we will need it, it'll be active. I would either leave up this window or copy this key and paste it somewhere. If you're new to my Python series, we have a little bit of setup to do. You will need the PyQt5 package installed. If you've been following my series, you can skip ahead to the following timestamp. At this point, we'll already have a basic window set up. To download PyQt5, you can open up a terminal and use pip, which is Python's package manager, to install PyQt5. And myself, I do already have this downloaded. Once you have this package downloaded, and it's within your site packages folder, we will need the following imports. We will import sys. Sys means system. It handles system variables for your Python interpreter. We will import the requests module to make a request to an API. Then we'll need widgets. Widgets are the building blocks of a PyQt5 application. From the package of PyQt5, access the module of Qt widgets. Import the following widgets: Q application, Q widget, Q label, Q line edit, Q push button. Let me put some of these on a new line for readability. Q v box layout. This is a vertical layout manager. To work with alignment, we'll need the following: from the package of PyQt5, from the module of Qt core, import the following class, Qt, which is used for alignment. So these are the imports that you'll need. Just to be sure that I didn't misspell anything or get the capitalization wrong, I'm just going to do a test run. No problems. Processed finished with execode 0. Sometimes I make one of these characters lowercase, and then it doesn't work. Okay, we have our imports. We will need to create a class of WeatherApp. WeatherApp is going to inherit from the parent of QWidget. We will need a constructor, so we'll define that. Dunder init, no arguments besides self. In case we have arguments to send to the parent, we will call the parent with super, meaning the super class, then call the constructor. But currently, we don't have any arguments. If we are running our main Python file directly, we can verify that with an if statement. If dunder name is equal to a string of dunder main. If we are running this file directly, then we will create a weather app object. Otherwise, we won't. If this statement is true, we will do the following. We will create an app object. App equals, call the constructor within our Q application class. But we will pass in the following: access the module of sys, then access argv, which means arguments. If we have command line arguments to send to our application, this is how we would take care of that. But we're not going to be using command line arguments in this video. But it's nice to future-proof our code, just in case we do. We will construct a weather app object. Weather app equals, call the constructor of our weather app class. Now, this window isn't going to show. We have to call the show method of our weather app. Weather app weatherApp.show. And now it's going to show for a brief second. We need to ensure a clean exit. Access sys, call the exit method. Within this method, we will pass in the following. Take our app, call the execute method, which is exec_. It is a method, so we have to call it. This method handles events within our application, such as closing the window. So now our window should stay in place until we close it. If you're one of the people that have jumped ahead, we have created a class of WeatherApp, which inherits from the parent of QWidget. We've constructed a WeatherApp object, and we're showing it. If you've made some PyQt5 projects in the past, you would just have to change some of these around. Within the constructor of our class WeatherApp, we will declare the different widgets that belong to our WeatherApp object. We will create a label that prompts the user to enter in a city. We will name this city label. Equals, this is a Q label widget. We can set the initial text of the label. Let's say enter city name. Then the second argument is going to be self. We are adding this label to our WeatherApp object. Here's what we have currently. We still have to do some CSS formatting, but we'll take care of that soon. We will need a line edit widget, basically a text box. We will name it city input. The widget is line edit. No parameters besides self. Here's our line edit widget. We're not currently using a layout manager. These widgets are going to overlap. We need a button, self.getWeather button. This is a Q push button. The text on this button will be get weather. We are adding this to self, our WeatherApp object. Here's our button. When we click on this button, we'll make a request to an API. For the next following widgets, we're going to add some placeholders, just so that we can see what we're doing when we apply CSS styling. We need a temperature label to display the temperature. Temperature label equals a Q label. Temporarily for the label, let's say that the temperature is 70 degrees Fahrenheit, or pick something else in Celsius. So to add a degree symbol, if you're using Windows, make sure numlock is on, hold Alt, then on the numpad type 0176. I will pick 70 degrees Fahrenheit. And then we will add this to self. Again, we're just using this temperature as a placeholder. We'll delete it when we do a test run. If you would like to include an emoji or some other image, we can create a label for that. I will name this emoji label equals a Q label. I will add an emoji of a sun as a placeholder. Again, we're going to delete this when we do a test run. We are adding this to self. Again, everything is overlapping. That is fine. And we need a description of the weather. Description label equals a Q label. As a placeholder, let's say that it's sunny. And we are adding this label to self. Okay, here are all the widgets. They're all overlapping. So we need to fix that. All right, moving on, everybody. So now we have to design the layout of our web app. Right now, all of our widgets are gravitating to the top left corner. So I will define a method to initialize our user interface. At the end of this constructor, we will call this method self.initializeUI, then call it. Once we've constructed our widgets, we'll format them and design the layout. So we are now within our initialize user interface method. First, let's set the title of our window. Self.setWindowTitle. Let's say that the title is Weather app. So that should change, which it does. We're going to use a vertical layout manager to handle all the widgets. Let's name the layout manager vbox equals, call the constructor of the class qvboxLayout. We're going to take our layout manager of vbox, then add a widget. We will start with the city label. That's first. We will pass in self.cityLabel, and we'll do this with the other widgets too. We have city input, get weather button, temperature label, emoji label, and then a description label. Take self, our weather app, set the layout. We will pass in the layout manager of vbox. And here's what we have currently. All the widgets are arranged in a column. Now we just have to center align them horizontally. Here's how. We will take self.cityLabel, call the setAlignment method, access the class of Qt, access the flag of Align Center. We're going to align all of our widgets in the center, except for our weather button. Currently, our button expands to take up the width of the window, so we don't need to horizontally align that. So we have 5 widgets to align. We have city label, city input, temperature label, emoji label, and description label. All of the widgets are going to be arranged in a column horizontally. Now we just have to apply some CSS styling, because right now it's kind of ugly. We will apply styles based on an object name, but we have to set that object name. So let's start with our city label, self.cityLabel, call the setObjectName method, pass in a unique ID for this widget. I will name it CityLabel. I'll keep it the same. Okay, we have to do this with the other widgets too. We have a total of 6. We have city label, city input. We have the get weather button, temperature label, emoji label, and description label. Then we're going to set a style sheet. Take self, our weather app, apply a style sheet with set style sheet. We have a lot of properties to write. I will do so within a set of triple quotes, just to keep everything more organized. We can apply CSS styles based on a class. So the class is going to be QLabel. Within a set of curly braces, we can list multiple CSS properties. I will set the font family to be Calibri, as well as all push buttons. Q push button. So here's the font, although it's still kind of small. Let's select our ID of city label. It's good practice to precede this ID with the name of the class. So QLabel, #, the ID. We precede the ID with the name of the class, just so we're only applying these CSS properties to any ID that's a city label that falls within the class of QLabel. Let's set the font size to be 40 pixels. Let's set the font size to be 40 pixels. That's better. I'll set the font style to be italic. Font style, italic. That's pretty good. Let's select the ID of city input. This is a line edit widget. Q line edit pound the ID of city input within a set of curly braces. Let's set the font size to be 40 pixels. We will select our push button, which is named getWeatherButton. The class is queue_push_button pound the ID of getWeatherButton. Within a set of curly braces, we will apply the following. Let's set the font size to be 30 pixels. And let's make it bold. Font weight bold. Let's select our temperature label. The ID is temperature label, and this is a Q label pound temperature label. We will increase the font size. Font size 75 pixels. Better. Let's work on our emoji next. We will select the ID of emoji label. The class is QLabel. The ID is emoji label. We'll set the font size first. Font size 100 pixels. I would like a large image. To display emojis properly, we're going to use a very specific font. We're going to set the font family to be, now I don't know if I'm saying this right, SEGOUI emoji. I probably pronounced this word wrong, but I don't care. So then our emoji should display correctly using this font. It's colorful. Then we have the description label of the weather. That is the last widget, description label. The class is QLabel. The ID is description label. Let's take the font size and set it to be 50 pixels. All right, so this is what our weather app is going to look like. We have the city label, a text box to enter in a city, the Get Weather button, the temperature label, an emoji label, and a description of the weather currently. Now we just have to add some functionality because currently this doesn't do anything. Alright, so now we just have to add some functionality to our weather app. Temporarily, I'm going to collapse our initialize user interface method. We will define a few extra methods. Let's declare a method of getWeather. No parameters besides self. I'll write pass for now as a placeholder. We will need a method to display any errors. Display error. There's going to be one argument besides self, a message. We will pass in an error message, if there is one. And a method to display weather. That's if there's no errors. We will need some data, our weather data. So be sure that you write these three methods. Back within our initialize user interface method, at the bottom, we have to connect a signal to a slot. When we click on the button with the signal of clicked, we will connect a slot of getWeather. We will access self, take our getWeather button, with a signal of clicked, we will connect a slot of self.getWeather. And I will print a test message, just to be sure that it's working. You get the weather. So I press the button, and we will display, you get the weather. We can get rid of our placeholder text for the temperature, our emoji, and the weather description. So we can delete these strings. But be sure to keep self. Scrolling down to our getWeather method, when we click the button, we're going to create a few local variables. The first is going to be our API key, equals, this will be a string. Back to the Openweather API, you will copy your API key and make sure that it's active. You can use the toggle button to make it inactive and active. So make sure that it's active. Paste your API key within a string. Please use your own. It still may take several minutes for your key to be active. Just keep that in mind. We will need to get the city that we're looking up. So let's say we type in Miami. I have to get the text from this widget, this line edit widget. We will create a local variable of city. City equals access our line edit widget. It had a name of city input. So self.cityInput, to get the text, we will call the text method. We have the API key and the city. Now we will create a URL. This will be an f-string. Using the request module, we will pass in a URL to make a request to. So back to our Openweather API. To get the URL for a city, we have to go to the tab of API, scroll down to current weather data, and there's going to be some API documentation. To the right, we have a link for built-in API request by city name. We will copy this URL and paste it within our f-string. There's two changes we're going to make. We will replace city name with city, the name of that variable, and API space key with API underscore key. It doesn't matter what you name these, just make sure they're consistent with your variables. When we make an API request, we will be returned with a response object. Response equals access our module of requests, call the get method, then pass in our URL. With our response object, we have to convert it to a JSON format. We will be returned with an object. We will name this object data. It's going to be readable to us. Data equals take our response object and use the JSON method to convert it to a JSON format. So let's print our data to see what we're working with. Let's say I look up the city of Miami. So we have one gigantic object. This is our weather data. We have coordinates, such as longitude and latitude, a weather description. Currently in Miami, there's broken clouds. There's an ID of the weather. This is the temperature, but it's in Kelvin. If we scroll all the way to the end, we are looking for an HTTP status code, which is named COD, short for code. 200 means that the response was successful. Depending on what this number is, we will display one of a few error messages. If our status code is 404, that means the city wasn't found. And there's many others. So 200 means that the request was successful. So let's write the following. If our data object at key of COD, if this is equal to 200, if the request was successful, then we will call the displayWeather method, self.displayWeather. But we do have to pass in our data. Now, temporarily, I'm just going to print our weather data. We'll do some more complex stuff later, but I just want to be sure that everything is working. So let's look up Los Angeles. So here's the weather in Los Angeles. There is currently broken clouds. And again, the status code is 200. The request was successful. I'll write an else statement for now. We will print our data. What if we can't find a city? For example, I will look up the city, blah, 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 and get the weather. So here's our weather data. We have an error code of 404 and a message of city not found. Let's do some exception handling in case we run into one of these status codes that's not 200. We can get rid of our else statement. What we'll do is enclose all of our dangerous code. That means any code that might cause an exception within a try block. we will try all of this code and handle any exceptions with an except block. There's two types of exceptions we're looking for. The first is an HTTP error. HTTP error is an exception raised by the request module when an HTTP request returns a status code that's 400 or 500. However, this exception is found within the request module that we've imported. So we can't simply just say except HTTP error. We first have to access the request module, then access exceptions. Then we can list the specific exception of HTTP error. We'll encounter this exception if the status code is between 400 and 500. And for now, I'll write pass. So there's one more step within our try block. If we're going to handle any HTTP errors, we have to raise an exception within our try block, because our try block by itself normally doesn't catch these. We will take our response object and call the raise4status method. This method will raise an exception if there's any HTTP errors. Normally, our try block doesn't do that, so we have to manually type this. There's another type of exception we'll catch, and that's the request exception. We'll add another block for except request exception. This is found within the request module. Requests, exceptions, request exception. With a request exception, this can be due to network problems, invalid URLs, exceptions of that nature. In case we run into one of those types of exceptions, we will execute this block of code, but for now, I'll write pass. We'll get back to it later. Going back to our except block where we handle any HTTP errors, let's use a match case statement. We need to get the status code of our response. I'll print that temporarily. Let's print our response object's status code and see what it is. Again, let's make up a city, get the weather. We have a status code of 404. That means the city wasn't found. Depending on what this number is, the status code, we'll use a match case statement. So we will match our response object's status code. The first case will be 400. That means there's a bad request. So let's print the following. Bad request. I'll add a new line character. Please check your input. We'll create a total of, I believe, 8 cases. We'll copy what we have. So we have 400, 401, 403, 404, that one we're familiar with, 500, 502, 503, 504. So for case 401, that means we're unauthorized. Maybe our API key isn't active yet. So let's say unauthorized, invalid API key. For 403, that means access is denied. It's forbidden. So let's print forbidden. Access is denied. 404 is for something that's not found. Not found. City not found. 500 is for an internal server error. Internal server error. Please try again later. 502 is for a bad gateway. Bad gateway. Invalid response from the server. .503 is for service unavailable. Service unavailable. Server is down. Then 504 is for a gateway timeout. Gateway timeout. No response from the server. In case there's any unexpected error, we can add a wildcard of an underscore. With our HTTP error, let's give it a name as HTTP error. And then we'll just print it. In case there are no matching cases, let's print the following. HTTP error occurred. I'll add a new line. Let's convert this to an F string, add a placeholder, and then I will print our HTTP error. All right, let's do a test run. So in case we can't find our city, we should encounter a 404 error. Not found. City not found. Eventually, we will display this message within our app. But we know that it works. What if my API key is invalid? So I will take my API key, set it to be inactive. But it might take a few minutes to take effect. The status code of our response object should be 401. So this time I'm going to look up a city, I have an invalid API key, and I get that error message of unauthorized, invalid API key. Alright everybody, so I am on day 3 of working on and recording this topic. Over the course of the day, I thought of one change that I can make. We're going to add a few extra accept blocks. So we will accept access requests, access exceptions. We will handle any connection error exceptions. As well as any timeout exceptions. And any redirects. Too many redirects. So, if we run into a connection error, let's say that our internet gets disconnected, well, we can print something. So let's print the following. Let's print connection error. I'll add a new line character. Check your internet connection. If we encounter a timeout, then we will print the following. We have a timeout error. The request timed out. If we have a too many redirects error, that M should be capital, by the way. Let's state too many redirects. Check the URL. And if there's anything else we don't anticipate, I'll give this exception a name of as rec error. And then we'll just print it. This is a last resort. I'll use an F string. Request error. I'll add a new line. I'll add a placeholder, then display our request error. So I'm actually going to turn off my internet. I'll see if I can get a connection error intentionally. So my internet is currently off. I will attempt to look up a city, get the weather, and we get a connection error. Check your internet connection. Alright, my internet is connected again. Let's perform a test run. And we get the weather in Miami. Now what we're going to do is, if we have an error, we'll display the error message within the app and not within our console. So we're going to replace print with a call to our display error method. Let me zoom out a little bit. So replace print with self.displayError. And we're passing in a message. So let's replace those. One thing I forgot to add, although it's not necessary, I'm going to add a colon after each initial message. I think it'll look better. You don't have to do this, but I'm OCD about the appearance. If we encounter one of these exceptions, we'll pass along a message to our displayError method and display it within the app. Let's take our temperature label, self.temperatureLabel, and set the text to be our message that we pass in. Let's do a test run. Let's look up a city that doesn't exist, get the weather. So we get that error message, not found, city not found. While we're within this method, I'm going to change the font size just so that it's a little bit smaller. So let's take our temperature label, self.temperatureLabel. I'm just going to copy this because I'm lazy. I will call the setStyleSheet method and pass along a new property. Let's set the font size to 30 pixels. Let's look up North Pole. I don't think that's a city. Oh, I guess it is. Interesting. The North Pole is a city, I guess. Let's look up blah blah blah. Not found. City not found. Let's do another test. What if our API key is invalid? I'll just delete one of the digits. Let's look up Los Angeles. Unauthorized. Invalid API key. Let's change that back. Again, I will turn off my internet. Then look up Miami. Connection error. Check your internet connection. Alright, so we know that our exception handling works. Okay, now we're within the display weather method. We'll receive an object to represent our data. We have to get the temperature, but first I'm going to print our data. So let me zoom in a little bit. Let's look up Houston, Texas. I need the temperature. Within our data object, we are looking for a key of main, and that is right here. Main contains a dictionary with key value pairs. Once we've accessed main, we have to access temp to get the temperature, and this temperature is in Kelvin. We'll have to convert it to Celsius or Fahrenheit. It's your choice. So we need to extract this value. I will store it as a local variable. Temperature. Let's say temperature underscore K for Kelvin equals, take our data object, access the key of main, that's right here. Then we have to go one level deeper and get the temperature. The key is temp. Then give me the value at the key of temp. And that should return the current temperature. So to test it, let's print it. Let's print the temperature in Kelvin. So what is the weather in Houston, Texas? The temperature, that is. 309 Kelvin. Let's convert it to Celsius and Fahrenheit. Let's create temperature C if you want to use Celsius. If you would rather use Fahrenheit, you can skip this step. To convert from Kelvin to Celsius, we will take our temperature in Kelvin, subtract 273.15. Then for Fahrenheit, let's take temperature F for Fahrenheit equals, this is a little more complicated. Take our temperature in Kelvin times 9 divided by 5, subtract 459.67. Okay, so let's print the temperature in Celsius. Let's look up Houston. 36.46 degrees Celsius. Then in Fahrenheit, that would be 97.6 degrees Fahrenheit. That's pretty hot. All right, so once we have our temperature, let's change the temperature label. Self.temperature label, I'll just copy this. Then we will set the text. I'll use an F string. Add a placeholder. I'll use Fahrenheit, but feel free to use Celsius. Then I will add a degree symbol. With Windows, make sure numlock is on. Hold Alt. Then on your numpad, type 0176 for a degree symbol. Then F for Fahrenheit. Let's look up Miami. Get the weather. And here's the temperature. 94.964. Now let's say I would like no digits after the decimal. I can add a format specifier. After our temperature, I'll add a colon, 0.0f to display no decimals. Let's try that again. I will look up Miami, get the weather. The current temperature in Fahrenheit is 95 degrees Fahrenheit. Now, here's one issue. Let's say we display an error, then display the weather. If we display an error, we're going to be changing the font size. So let's look up blah, 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 get the weather, city not found. Then let's look up Miami again, get the weather. And the font size is a lot smaller. So if we display the weather, let's reset the font size. We can really just copy this line. So within the display weather method, let's set the font size back to 75, what it was originally. Let's try that again. Let's look up a city that doesn't exist, get the weather, city not found. Then we'll look up a city that does exist, like Miami, and get the weather. 95 degrees Fahrenheit. Now let's get a description of the weather. We'll display that at the bottom. In the center, we'll display a picture or an emoji, but we'll handle that last. Now we need a description of the weather. Like, is it sunny? Is it cloudy? Is it raining? So after we calculate the temperature, so I'm going to print our data again. Let's look up Los Angeles. So currently it's 85 degrees Fahrenheit. So for the weather description, that is found at the key of weather. We're now within a list. At index 0 within our list, we'll look up the key of description, which states clear sky. So we will create a local variable of weather description equals access our data at the key of weather. There's layers to this. We're then within a list. And actually, it's a list with only one item in it. So at the index of 0, then at the key of description. That's going to return this description of clear sky. So we will take our description label, self.description label. Let me just copy it. This one right here. Then we will set the text. And then pass in our weather description. What is the weather description of Los Angeles? 86 degrees Fahrenheit, and there's a clear sky. Okay, now the last thing we're going to do is add an emoji. We'll add it right to the center between the temperature and the weather description. You don't necessarily have to, but I think it'll look cool. And that's a good enough reason. So let's create another method to handle that. We will define a method of getWeatherEmoji. Or a picture if you would rather use a picture. We don't need self necessarily. We're going to need a weather ID. This method isn't going to rely on any class data or instance data. We could make it a static method. I'll add a decorator of static method. In summary, a static method, we haven't covered these for a little bit. They belong to a class, but don't require any instance-specific data or any other methods. They're used as more of a utility tool. We're going to be passing in a weather ID and returning an emoji. I'm going to show you where we can find that weather ID. I'll use a print statement. I will print our data. Let's look up Miami again. That's the first thing that came to mind. Now, at the key of weather, there's a key of ID, and the value is a 3-digit number. I'll show you this chart. Depending on what this 3-digit number is, that corresponds to a certain group of weather. So the 200 range is a thunderstorm, 300 is a drizzle, 500 is rain, 600 is snow, 700 is atmosphere, like if there's a tornado or there's a volcanic eruption. 800 exactly is a clear sky. Anything that's 801 or above refers to clouds. So this ID is 803. We have broken clouds. Depending on what this ID is, I would like to return a certain emoji based on the weather. So we need this ID. I'll delete our print statement. We no longer need it. Let's say before our weather description, we will create a local variable of weather ID equals access our data object, then access the key of weather. The value at weather is a list, but this list only has one item in it, so we need the index of operator at 0, and then we will access the key of ID. The key is ID. So our weather ID is going to be a number, a 3-digit number. Okay, everybody, we're near the end. So after setting the temperature, we're going to set the emoji label. Self.emoji label, and call the setText method. Within the setText method, we will call self.getWeatherEmoji method. This will return a string, an emoji within a string. But we have to pass in our weather ID. It's that 3-digit number. So now we are within our getWeatherEmoji method. Depending on the range of that 3-digit number, we will return one of a few emojis. We could use a match case statement. I think it's more complicated with the match case statement. We'll use else-if statements for simplicity. So if our weather ID is greater than or equal to 200, and our weather ID is less than or equal to 232. Now, we have two conditions here linked with the AND logical operator. There is a shortcut to this, and actually PyCharm is telling me that there is. We can simplify these expressions. Instead of two separate conditions, we can combine them into one. If 200 is less than or equal to our weather ID, and our weather ID is less than or equal to 232, if this one combined condition is true, then we will return an emoji. So to add an emoji on Windows, you can hold down the window key and press semicolon. So 200 to 232, that's for a thunderstorm. Depending on the font style of your IDE, some of these emojis might not display properly. You can always just copy them from someplace else. I think that's better. It's more colorful. Then else if 300 is less than or equal to our weather ID, and our weather ID is less than or equal to 321, this is for a partially cloudy sky. We will return some clouds, a partially cloudy sky. And again, I don't like that one, so let's use this one instead. Else if 500 is less than or equal to our weather ID, which is less than or equal to 531, we will return rain. That's better. 600 to 622. Else if 600 is less than or equal to our weather ID, which is less than or equal to 622, we will return snow. So 701 to 741 is mist or fog. Else if 701 is less than or equal to our weather ID, which is less than or equal to 741, we will return some mist or fog. 762 specifically is for ash, like from a volcano. So else if our weather ID is directly equal to 762, we will return, let's return a volcano. 771 is for a squall. That's a violent gust of wind. Else if our weather ID is directly equal to 771, we will return, let's return that, a violent gust of wind, a squall. 781 is for a tornado. Else if our weather ID is equal to 781, return a tornado. 800 exactly is for a clear sky. Else if our weather ID is equal to 800, return a sun emoji. Else if 801 is less than or equal to our weather ID, which is less than or equal to 804, we will return some clouds. Now, if there are no matches, let's return an empty string to not display anything. Okay, let's do a test run. Let's look up Miami. We get scattered clouds. It's 94 degrees. Los Angeles. Get the weather. We have a clear sky and a sun. Now, there's one fix we need to make. Let's say that I make up a city again. Blah, blah, blah. Get the weather. We should clear our emoji label and the weather description, but we still get that error message. So after we display our error within the display error method, after we set the text of the temperature label, let's take the emoji label, self.emoji_label, and call the clear method to clear it. Then we have to do this with the description label, self.description_label, and call the clear method. Now we should be able to clear it when we get an error. Okay, let's look up Houston. Get the weather. Few clouds, 98 degrees. Let's make up a city. Pizza City. Get the weather. Not found. City not found. And the emoji label and the weather description are cleared. Okay, what if I type in nothing? What happens? Let's get the weather. We have a bad request. Please check your input. That's if we have an HTTP status code of 400. We handled this exception. Bad request. All right, one last city. What about Paris? Let's get the weather. It is 68 degrees Fahrenheit, and there's light rain. All right, everybody, so that is a weather app that you can make using Python. Add it to your portfolio, and thanks for watching.